that they are doing their own. For example, let me show in my last talk when I talk about robots, I mentioned that Tesla is doing their own robots because when they move the factory from China to Mexico, they're not going to hire people in Mexico to assemble the cars. They're going to build an army of robots that will do that. So think about it. Okay, so this is the one that 11:15, that's today. So this one I didn't know until I walked into and Daniel told me, have you heard that Microsoft is doing their own AI chips? Okay. So they are saying they are coming with a Maya chip and a Cobalt chip, all for different applications. Okay, and they're all being manufactured by TSMC. So when you are investing in AI stocks, still buy TSMC because after all, everybody is using the TSMC chips. They can do their own design of the chips, but where does it get manufactured? The chips is still TSMC. Yeah. Okay, so as a matter of fact, here's the picture. I did all that stuff here this evening before you guys came up. I say, Daniel say, well, did you heard about the Maya and the Cobalt chip? I said, no, but let me just Google it and I'll do it and took a picture. Here's the way that looks that the Microsoft Cobalt and Maya chips. Okay, because I need to wrap up, so I'll wrap up in 1 minute. So this is the summary and conclusion slide, and then you can ask me any questions that you want. Okay. So we said that right now AI is hot, and because AI is hot, you need AI chips that run fast. As a matter of fact, there was a conversation that we had before the seminar started. That's saying that right now, you know that the energy consumption on the world is not only the number of people in the planet, but all these new applications are suddenly AI, and suddenly climate change, and all this stuff, all requires a lot of compute power. So we need a lot of energy, not only for our own household lives, but also that. So we talk about why this AI chip, why do we need AI chips? We talk about the variations of AI chips, GPU, DPU, NPU, TPUs. We talk about how do you select it depending we're trying to do modeling or inferencing, or we're doing edge or cloud. And then we cover most of the leading players. Okay, so that's the talk for tonight. It actually still went over pretty good. Originally, I thought I was going to wrap up in 1 hour, but because of the couple questions, we delayed by 15 minutes. Okay.
The last slide talk about the Microsoft 2 chips. So that means to do AI job with the 2 chips.
That's right. You can have 4 chips.
No.
You can say 1 for data center, 1 for cars, or different things.
They call the pocket. The other one they call the facility.
One's modeling, one's inference. Okay, so those are the 2 from the software standpoint. Okay, but then depending on what you're going to use it for, whether it's in the cloud or it's going to be on the device. If you're using on IoT, you're going to be talking about this edge. Okay, so that's it. That's the end of tonight's talk. So now you can ask me any questions. There's no time limit. No, Microsoft is trying to sell your software. Like for instance, all your PowerPoint, all your Office software, they sell you software, okay? But when you go and buy Microsoft, you can ask him questions. So Microsoft invested in OpenAI. OpenAI is the company that did the ChatGPT, the AI software. And Microsoft didn't develop their own, but they acquired. They invested $6 billion on OpenAI. So they say, everything that you develop, we'll put into the Microsoft product. So right now, ChatGPT and everything is in any of the Microsoft products. Word, PowerPoint, to take it. Yes, as a matter of fact, they have a slightly different interface than ChatGPT. So ChatGPT is just ChatGPT. Okay, but you can access ChatGPT via Microsoft, and the packaging, the interface is a little bit different. the user interface system. Huh? Oh, yeah. Right now, there's a GPT-4. There's a thing. It's much faster and everything.
But Microsoft is number 2 cloud service provider.
That's right.
So
Amazon. Through the, well, they have a Microsoft, I don't know what they call it.
either one or
Azure, or whatever,
two.
yeah.
So Microsoft is very fit into this hardware.
Well, as I said, it doesn't matter what you are in. If you're selling something like a service, you need the AI. Right now, if you like if you're an entrepreneur and you want to get funding, just make sure that in your proposal it has AI, right? So I'm using the latest AI. Okay. Now you got the money. You don't, okay, where's AI? I don't see AI, forget it. No money. That's as simple as that.
I'm surprised. IBM is small in cloud service. Yeah, not
No.
IBM.
IBM actually is into everything. IBM is into quantum computing.
Yes.
You know how much a quantum computing costs, right?
More than
And IBM is also into service. So for instance, they have the thing called Watson. Watson is actually a quantum computer. And you can just like ask ChatGPT. You say, well, I have a task that is very computing intensive, and I don't have the money to run it. So then you can go and say, okay, IBM, can you sell me time on Watson? I mean, just like if you don't have enough money to have your own cloud, you can go and have a cloud. So that's the way they sell it. There's the rich people, they sell you services. You go and pay me anything, and I'll give you whatever you want. Yeah.
It's a cloud, for every application, it's on cloud.
Yes, actually, yes and no. First of all, not everything needs a cloud. Okay, but there are different clouds for different applications. That's what now they call it vertical clouds. It's like, for instance, a cloud that is good for medical. Okay, so that cloud is good only for medical knowledge, but it's not for a computer or for IT or for other things. So what they have is that, because otherwise the cloud is, if cloud is like Wikipedia, where it has to know about every subject domain under Earth, imagine what's the size. So right now the trend for AI is going to be into domain specific AI. It's not, why do you need ChatGPT that knows everything about how to go to Mars? If you're not even college educated, who cares what's the speed of the rocket? How it's going to land on the backside of the moon. You need only what you need. Okay, so you don't want to pay for the whole enchilada if you're going to have only one very narrow application, right? So that's why everything is just like the universe. When people say, oh, the universe expanded, after it expanded, it contracts. So the reason why ChatGPT took everything by storm is because everybody say, oh, I can use ChatGPT. No matter where you're a chemist or you're an engineer or you're a writer. You say, oh, I can use ChatGPT. So that's why it took off, because everybody felt that they could make use of it. But now that it's available, they say, well, I'm a writer. Why do I need to know how to do chemistry? I don't need to know. So I want to buy only that portion of it that's relevant to me. So, everything contracts and then contracts.
Seems like the cloud for every field will be used by a lot of different applicants. So who will be the organization to be in charge of one cloud for one everything? And some book, right? An organization that.
Yeah, it's actually, the answer is very simple. Okay, so I mentioned that first you catches everybody's attention with ChatGPT, because ChatGPT can help you and it can help him and can't help that, right? Then you realize, well, I don't need the whole thing. I'm a cook, so I only need to know how to prepare dishes. I don't need to know how the matrix multiplication and the convolution thing works. Right? So who does it? Whoever owns the domain knowledge. So let's say right now, one of the main topics focused on AI is biomedical, because we're all humans and we're all getting old, and eventually we all need to take care of our bodies, right? So let's take that as an example. Who is going to do that? The hospitals, the Department of Health, NIH, those are going to do it. Now, you will say, well, I'm into the record business. You're going to go on the companies that do music. So everybody has their own. Today, even without AI, there's an owner for everything. It's not like one company or one person doesn't make the decision for everything. It really depends on your domain knowledge. That's right. That's right.
That's Wikipedia.
Okay, so I don't know where the people who are manning the thing from the Zoom, where they had any questions or not. But no.
You can buy.
You want to just go to the chat and see were there any questions from the. Let's see. You can close this one and then go to the Zoom link.
Yeah, for sure. There's the chat box here.
Okay.
These are from 8:23.
Okay. Is it from here to here?
Yeah.
These are the questions?
Yeah, question should be a start from this one.
Okay.
From class. Thank you, Dr. Clark.
Okay. Okay. Some of these are not questions, just comments.
I don't see any questions in the chat box.
Okay, so there's one question actually from the Zoom that maybe I can answer. They ask, when do you use FPGAs? Okay. So the answer is actually quite simple. If you go back to the old days when we were working on semiconductors, when do you use FPGAs? Is that when you want to do a prototype. Okay, because you want to have fast turnaround, you can just reprogram it. You can know the results. And once you're happy with it, then you can make a ASIC.
Yeah.
Right? So fast prototype is the best use for FPGA, because you can experiment results very fast. You can do experimental things fast.
Modify your program.
Right, and then you can modify. And after you're done with that, you can reprogram it to do another. It's sort of like an experimental chip. It's sort of like an experimental chip. That's what the FPGA is.
The FPGA, the performance and its density is much less than.
You're absolutely correct. Because it's not as fast as an ASIC, because ASIC can do certain things very fast. It's what's good. But FPGA, you have to reprogram it. But the programming, first of all, it takes two efforts. One is you have the programming part. Okay. The second thing is not going to be as efficient as an ASIC. Yeah. So you're absolutely correct. But everything is already embedded in the FPGA. The only thing you have to do is the software program.
Yeah,
ASIC is just everything is a hardware. Okay, FPGA is more like programmable. But you don't need to add the additional thing. The FPGA is FPGA. You just the way you interact with FPGA is via software programming.
So the prototype that you come out with using FPGA, that will not be the same as the device you use in ASIC.
Okay, let me tell you what is a prototype. Okay, a prototype means that it's not the best, it's not the fastest, but it can tell you. Let's say you want to say, what would this do? Okay, so it will give you the answer, the functionality, but it's not the most efficient one. When you want to go for the most efficient and the cheapest, you go to ASICs. Okay, but the thing is that you don't know, and you don't want to go and design an ASIC and then, oh, it didn't work, so let me try another ASIC. ASICs are expensive. ASICs are only for large volume. When you already know exactly what you want, then you can mass produce. Okay. Okay. Everybody know a little bit more than when you came in? Okay. Thank you for coming. Thank you for coming. And this is actually my last seminar for this year. So God permits, we'll see you next year, but that will be in January. Okay. No, my first talk, actually, that's a good question. My first talk for next year, and this is a recurrent thing. Every year, the first seminar in January, the title is called 2024 Technology Trends and Predictions for that year. So every year, the title is the same except the year. So this year, when I gave in January, was 2023. Technology Trends and Predictions. For January next year, what is usually in January, I give a prediction of what's going to come. Okay, so say, oh, these are the things to watch for.
You ever go over like, oh, I was wrong about this, right about that?
No, I never go tell father I'm wrong. You mean from these ones? From the topic today or the future? Oh, yeah, I already have the material. It should prepare. Actually, I already have my slides for the January talk already done. Let me see you. Let me see where I can show you what the cover looks like. Okay. So if you like the picture, then you can comment. "2024 Technology Trends and Predictions." That's going to be the next talk. It may or may not be the 17th because I have not really tried to book this room.
So the trend is still will be AI.
Well, yes, it will always have AI, but there will be other things. Here. As I said, I already have most of the slide prepared. So if you're interested in any of these topics, come and come. So AI, right now, everything AI is gen AI, generative AI. Okay. But then there's also like biometrics, which is like the facial recognition, other recognition, quantum computing, a lot of other things that sort of revive. Quantum computing has been in the emerging technology for so many years, but it's always many years away.
The speed is faster.
Quantum computing and all of stuff.
Nobody knows the limit of the speed.
I'll leave you for 2 words so that you can Google it if you want to know before my talk. Quantum computing, 2 words that you can type in. What is superposition and what is entanglement? Superposition and entanglement. Those 2 are the key for quantum computing.
Okay. I think the mystery is the speed of quantum. Nobody knows what's the limit. It's much faster than light.
Yeah, but the minimum why people are so interested in quantum is because the minimum speed over the traditional computers is already more than 1,000 faster. But the upper limit you don't know because you depends on the number of bits.
Yeah.
So anyway, so if you want to follow up, but these are some. There may be some other topics. This is what I have already today. So I already have I don't know how many slides on this. I can see just so that because you are here, you get the benefit. Because I'm not showing this on the
any CPU. You don't know why. Not for any why.
So currently I have about 33 slides, so I'm still working on it. But there will be some more stuff. So I still got about what? Month and a half, almost, or 2 months to go to prepare this stuff. The way I prepare is that every morning when I get up, instead of watching the news, I go and type in, say, what's new in technology? Okay. And just like, for instance, I didn't catch the one that Daniel talked today about Microsoft, 2 chips. But every morning I go and say, oh, there's something new. And if I think that it's worthy to talk about it, I'm going to.
Why is Microsoft?
Huh?
Why is Microsoft?
Why? Everything is very simple, cost. Because if you don't do it, then you have to go and pay for somebody to do it. That's simple as that.
Thank you.
Okay. Thank you for coming. All right. Okay. Bye-bye. So for